Before we talk about the reactions and the mechanisms behind them of gluconeogenesis, I just wanted to mention other ways that we can integrate other compounds into the process of gluconeogenesis. And for the purposes of this diagram, I'm going to talk about lactate, amino acids, and glycerols. So lactate as a product of either fermentation or in other types of organisms as a direct product there, but amino acids from protein, and then glycerols obviously from fat. And lactate is converted into the gluconeogenesis pathway via the use of lactate dehydrogenase, which converts it to pyruvate. Not a lot of room there. Lactate dehydrogenase reacts to give us pyruvate. That's nothing new. At least in this context, we're familiar with that already. For amino acids, the book doesn't give a specific mechanism as to how it works. I imagine it's probably long and very complicated, but nevertheless, amino acids can be broken down and converted into pyruvate. We've already talked about other compounds being intermediates in biosynthetic pathways, so it makes sense that the reverse would be the same. And then for glycerol, which comes from triglycerols, from fats, right? It's going to react with something known as a glycerol kinase, which kinase enzymes, hopefully you know what those do at this point, and ATP. So we're going to be phosphorylating it. And then once we phosphorylate it, we're going to react it with, I'll just do it in white, NAD+, and then an enzyme known as glycerol phosphate dehydrogenase, which anytime you see dehydrogenase, I didn't mention it here, but dehydrogenases generally tend to work with redox reactions, and in this complex, NAD is going to be converted to NADH. And the two main products that we get from this are obviously NADH and dihydroxyacetone phosphate, which this can obviously go on to do gluconeogenesis or glycolysis.